Cool. All right, so as before, Mike and I will be recorded. We've got the inbuilt mics, but anyone that asks a question, we can repeat it and include it on the actual recording itself, so it can be heard. Okay, so what we're going to do this week is we'll start with that particle system. Now, to begin with, if we're in our content browser, we can right-click and just go Niagara System. Niagara is the name of the particle system inbuilt in Unreal. There is technically another one that is much older called Cascade, but that has not been in active use for a long time. Niagara gives you a lot of customization options. It integrates well with the material system. It integrates well with C++ code and blueprints. And it also has the ability to run simulations on the graphics card instead of the CPU, which is actually really important these days for particle systems. It can also do sprite-based or image-based particles or mesh particles as well. So when you create a new system, it will actually ask you if you want to have a completely empty system or whether or not we want to start with an existing system or emitter. For this one, I'm going to select directional burst. I'm going to hit create. And for the name, we use the prefix NS underscore for Niagara System. And I'm going to call this one Spike Trap Particle. Now, when we actually open this, we will be greeted with this, this window here. So this is the particle, the Niagara editor. So there's a couple things going on here that are actually quite important. Obviously on the left, we've got kind of this view of the actual particle system itself. This is doing a playthrough of what it looks like. And it is by default set to loop, so we can just see it repeatedly. This blue box here with a bunch of properties, user parameters, spawn and update, this represents the system itself. So just to give you an idea, one of the things that we can do is in the system, if we have a look on the details, there is an option for loop behavior. And this loop behavior is basically, how do we want it to work? Do we want it to be looping infinitely, so it constantly does the particle effects? Do we want to do it once, or do we want to do it for a set number of times? For now, I'm actually just going to hit once, but we'll come back to this. You'll still see it loop in the preview, but in the engine, it will only run once. This orange / brown box here that's currently named directional burst is our emitter. A particle system can have one or more emitters working together. They can even be tied to each other, so you can have the output of one emitter as the input for another. But typically you will see when dealing with particles, today we'll have just one, but more often than not, it will actually be a combination of emitters working together. Mike, you had a really good example that you mentioned yesterday.
Yeah, I like to, first of all, just liken this to, with the AI week, we said how complex behavior emerges from very simple rules. It's like that with particle systems. What looks complicated is often just several simple emitters working together. So a quick example, I like to think of like a fire. You would have possibly one, maybe two emitters for the flames. You'd have another one for the sparks or embers, another one for the smoke, probably another one even for things like heat haze. So there's about 5 separate emitters which would accumulate together to create something that looks quite complicated.
Yeah. And so I would definitely encourage having a play around with these because you can do a lot. You can also create your own custom code or blueprints for this, but typically we don't need to. The one thing that I will mention is the life cycle of a particle. So inside of this, basically this block here, you'll notice we've got spawn update for the emitter, and then spawn update for the particle and a renderer. So emitter spawn and update, we can set settings for the emitter itself, and then for particle spawn and update, we can set the parameters for individual particles. At the moment, the default is doing a spawn burst instantaneous. So that is saying that the emitter is going to spawn a bunch at once. And in the particle spawn, we initialize it with a bunch of different values. So random lifetime, we give it a color, we give it a random scale. And we also add velocity in a cone. So this basically kind of does like a shotgun burst out of a cone shape. Inside of update, you'll notice we have particle update, which is basically just tracking whether or not the particle needs to be destroyed when its lifetime ends. But you can also see that we're applying gravity, we're applying drag, we're kind of messing with the color through scaling it, and then we're using here solve forces and velocities to bring that together and actually apply all of this different physics. So it is actually applying physics to the particles themselves. And in case you're wondering, it's not something we cover today, but it is also possible to have the particles themselves be physics objects, so that if they are in a scene, for example, you might have sparks that then bounce off the ground. So you can actually do that through the particle system as well.
Yeah, and as you're watching this demo, I think it'd be valuable to also think about how would you do this without the particle system, and that will show you the benefits of Niagara, of what we're using here. It does so much for you in terms of you would be in charge of spawning these things, you'd be in charge of their life cycle, how do they move, how long do they live for, you're in charge of destroying them or reusing them. This is even rendering them more efficiently than you would be able to as well with very quick code. It's moving them very efficiently. So it's really making life so much easier, this system.
Yeah. Now, this directional burst is all well and good, but I'm actually going to go delete a bunch of it because we don't need it. I'm just using this as a good starting point. What you can do when you create a particle system is you can start with no emitter and create your own custom one from the ground up. But often what I like to do is I'll try and find the most similar one to what I want to do and then break it down and then just add my own stuff. So first things first, we're going to be doing a spike trap that shoots spikes up from the ground. We don't actually need velocity, so I'm going to delete that. And you'll notice here, without the velocity, it's kind of just a sad drop down, and that's because of the gravity that's being applied. The other thing is I'm going to keep the particle state, but I don't want gravity, you're gone. And you'll notice now it's just a dot, because it can't even move. I'm also going to get rid of drag, I'm going to get rid of scale color, I'll keep solve forces and velocity, just because that's always worth having, but I will get rid of this scale as well. And then finally, I don't want to use a sprite, I want to use a mesh, so I'm going to delete that. So now we're left with this. We're at the point where it is actually going to give us an error because it doesn't actually have properties that it needs to run. Because we aren't telling it, we're spawning things, but we haven't told it how to actually show that. So first things first, I'm going to click on render. There is a plus button here and add what's referred to as a new module. And I'm going to select a mesh renderer. And you can kind of see up here, it's a bit small at the moment because I deleted all the other forces, but it is now actually spawning a tiny little mesh. In the details, I'm going to get rid of this one, and I want to use a cone. Now, you can see that I have a cone here, but just to give you an idea, if you ever come into this and you type in for cone and you can't see it, if you click on the little cog, you can do show engine content. And by showing the engine content, this will give you access to any of the meshes that are stored within Unreal and not just our project. And you can see that there is a cone here, which is what I want. And now that I've done that, it's now spawning in. So that is our mesh renderer done.
If we were doing this lecture 15 years ago, that wouldn't exist. So traditionally, particle systems were often just camera-facing little billboards or planes like a sheet of paper with a transparent texture on them, and we'd use them for soft, fuzzy phenomena like flames and dust and sparks and things like that that you can't model out of hard geometry. But this is a more modern feature of most game engines where we can emit really any mesh we want, and it's still managed and moved by the particle system. So this is a very sort of contemporary example of how to use a particle system.
Yep, very important to note because yes, they weren't common until, I think Niagara was probably the first one that actually started to push for mesh rendering in particles. Cool. So let's actually change a couple of the things. At the moment, we've got a loop duration of 5 and it is running once. We do want it to run once, but having it hard-coded to only be 5 seconds and that can never be changed is a bit of a problem. In the bottom left-hand corner here, we have parameters, user parameters, and local modules. User parameters can be set up here. we can create them to give them values that we can use to override parts of the details inside of the emitters or the actual system itself. What makes this exceptionally powerful is that user parameters are accessible from C++ and blueprints, so we can control them from code. So if I go to user parameter here and I type in float, so I'm going to make a new float parameter, and I'm going to call this one, what am I going to call it? I don't even remember what I called it, so that's fine. We'll call it system duration. Actually, let me pull up my notes, apologies, because these are case sensitive and it will come back to bite me if I don't do this right.
I'll just echo a point Josh made. As programmers, the final value of these parameters is not our job, but what our job is in this case is to expose as much control as possible to the artists who are going to be configuring these systems.
Yep. So I'm going to call it system duration, and I'm going to set it to 2. So this will be the length of our system, so how long our particle system actually runs for. Now, inside of system state, where we have this loop duration, I can actually just click and drag this into here, and what that'll do is that now says that that loop duration is equal to the value stored inside of our user parameter. So we can now control that from code. Now, the other thing that I want to check is the emitter state, because the system can loop, but so can the emitter. And what I want to do is I want to make sure that the lifecycle mode is set to system. And what this means is that it will match whatever the system settings are. So it will also only run for 2 seconds. Now, let's jump to a couple other things. So spawn burst instantaneous. As I mentioned, this is what controls the particle spawning. And you can see here that we do a spawn time of 0, and we have a spawn count. I'm going to create another float, and this is going to be num spikes. And I'm going to set this to 100. And I'm going to drag this across and replace spawn count with this. Now it is going to say make in from float, so I probably should have made that an integer, but that's fine. It's going to work it out. We don't really care too much. But now, this also gives us the option to control how many particles we're going to spawn from code as well. Because keep in mind, we've got our base spike trap that we're doing, but if you think about a tower defense game, you want your traps to be able to level up. And that might change the color, it might change the size, and if we're changing the size, we might want to actually change the number of particles that we spawn in. So that is our spawn burst. Let's move to initialize particle. Now, at the moment, we can see that it has a lifetime set, and this is set to a random value between 0.8 and 1.75. We want to actually set this to a value, so we're going to do direct set, and I'm going to use system duration for this as well. So the particles will last as long as the system does, which is 2 seconds. And then it will delete itself. Now, you'll also notice we have a color here. This isn't actually doing anything at the moment. We'll leave it for now, but we will come back to it. The other things that we're interested in is sprite attributes. We can set this to unset because we're not using sprites, but you'll notice we have mesh attributes and we have our scale here. So what I'm going to do is I'm going to set this to a non-uniform scale that we can set, and I'm also going to create a parameter for it, which will be a vector, because it's obviously 3 values. And we will call this one spike size. Yep, we'll go with that. And I'm going to set its x and y to be 0.5, 0.5, but its z is going to be 1. So I'm going to make it actually much narrower. And you'll notice that when I drag this in over the mesh scale, it will immediately change the shape of the particle up here. Now, it is a bit annoying that they're just kind of spawning in one spot. There's actually 100 of them spawning on top of each other. That's the next step that we'll get to. So inside of particle spawn, I can click add. And what I want to do is I want to do a shape location. And you'll see immediately by the fact that I've added one, it is now spawning around a shape. By default, this is going to be a sphere. And in case you are curious, you can actually have a bit of fun with this. I'm trying to remember which way to do it. You can do... Yeah, so you can actually change it if you wanted to with the rotation settings to have them all like coming out of a sphere. Not too worried about that one for now, but what I am going to do is I'm going to change the shape primitive from a sphere to a box/plane, and then I'm going to set it to a plane. And now you'll notice it's spawning in kind of that plane shape. So it's actually spawning, if I can move it up, you can see that it's spawning in kind of a plane shape. Now it is still randomized, but it is spawning the way that we want it to be. Now, for the size, it is currently set to 100, 100. I am going to hard code this to 90, 90. And this is just so that it's within the bounds, because we know that our spike trap is going to be some multiplication of 1 meter or 100 by 100, right? So this means it will actually just be kind of compacted in. If we wanted to make sure that none of the spike bases kind of stick out from the sides, we may want to drop it to 85, but this should be okay. Now, the other thing that we want to do is for our scale mode, we want to set this to, so we've got non-uniform here, and it's set to 111 by default. This is okay, but maybe we want to customize this. And again, keep in mind, our spike trap, we've set that up so that it is 3 by 3. So if we spawn this in, it would only be in the center. So what we'll do is we'll actually create another parameter that is a vector, and this one will be, we'll do this spike spawn scale, and by default we'll set it to 1, 1, 1. And then I'm going to drag this across. And this just means that we can control it from code. So we can then scale it up to be the same size as whatever our spike trap ends up being, whatever size it may be.
Yeah, and what you're seeing here is how this is a system that really rewards experimentation. But that said, what I've often found is as I'm making a particle effect, regardless of what engine I'm in, I often still find myself configuring the same settings, even if I'm making drastically different looking effects. But you will see patterns. The more effects you make, you'll start going through sort of the same checklist of how many are spawning, how often do they spawn, what's the randomness, what volume are they spawning within, how do they live for. You kind of go through that same internal checklist in your head.
Again, as Mike mentioned before, simple rules, complex behavior. So these are all just very simple rules that we compound on each other to get the effect that we want. Now, at the moment, this is cool, but it just means that our spikes kind of just appear and then disappear, which is a bit boring. So let's modify it so that they actually start flat and then shoot up. To do this, inside a particle update, I am going to create a new module, and this module is going to be called Scale Mesh Size. And so by default, it's going to be 111, so it's not going to do anything. That's boring. But here's where we can actually use another powerful tool. If I click on the drop-down list here, one of the options that I have is I can do vector from a curve. And it'll appear here, and you'll notice immediately it is now doing a default where it starts from 1 and then goes down to 0 on every axis. So over time, over the lifespan, it is actually following this curve you can see on the right-hand side. And we can change this if we want to. We can do something like this, which will actually, I click that. It's going to misbehave, that's fine. But you've got a bunch of different types of curves that you can set, or alternatively, we can create our own. I'm going to click this button here, just because this shows it in the curve editor down here, which is a bit bigger and nicer to deal with. The first thing you'll notice, if we have scale factor here, because this is a curve that we've set, and we have X, Y, and Z. So each of these have two what's referred to as keyframes, which are these tiny little triangles. And the first one is at 0 seconds, and the second one is at 1, which is 1 second. Now, for X and Y, we don't want to change these. So I can click this second triangle, and you'll see that I have two values here. The first one is time, the second one is the value that we want it to be. I'm going to set this to 1, so that now means that the X is not going to change. If I select Y and do the same thing, set this to 1, you'll see now that it isn't doing X or Y, it is just doing Z. For Z, I'm going to select the first triangle this time and set this one to 0. And I'm going to set a second triangle, and I'm going to change it to 0.1 for 1/10 of a second, and I'm going to set this to 1. And now you'll see that it kind of punches up as the particle system goes through. Now, if we're not happy with 0.1, we could do 0.05, kind of make it faster. You can, again, play around and experiment with these values. So that's one thing. However, there is a catch to this, and it has to do with the cone's pivot point. So if I jump back to the third person level quickly, I'm going to click on Engine and just type in cone, and I'm going to drag one into the scene. So pay attention to this. That little dot there, whenever we've got that widget showing us our objects when we select them, that is the pivot point of that object. And rather annoyingly, the cone is actually kind of set to 2/3 of the way up. So what this means, and I can visually show you this as well if I mess with the scale, have a look at where the scale pivot is. Notice how it's in the center. That's a bit of a problem, because again, we want our spike to punch up. If we have it with just the pivot point, it's actually going to start in the middle of the air and then go up and down at the same time to get to the position that we want. So annoyingly, we're going to have to add another module, and this module is actually going to be a moving offset. So it'll offset it so it starts at the bottom and then slowly moves back to its default position as the scale occurs.
Yeah, this is where in the real world it's nice to be friends with your artist, because they would open this up in Maya or Blender and in 3 clicks they'll move that pivot. In this case we want it at the bottom and then it will grow from that pivot. We do that with trees as well, so we can scale them and they remain grounded on the terrain. In this case though, we can kind of sort of somewhat hackily get around it. Another way to get around it sometimes is by using an empty parent. So I've found myself occasionally needing to animate in code like a swinging door. It's pivoted in the middle, most primitive shapes are. Put a parent on the side, the door's the child, you animate the parent. So you can kind of fake it too. But yeah, today we'll just go with the quick option.
I will just quickly point this out to you as well, because it's even a problem that the Unreal developers have come across themselves. So this is our third person character. This is our default, right? The capsule component, its pivot point is in the center. Look at where the pivot point is for our character. It's at its feet. Now, if I just added this character, it's actually going to look like this, because it is a child of the parent, and it will try and set itself to the pivot point so that they align. Inside of Unreal, if you ever have a look at your character, you'll notice when you select the character mesh, its location is -89. So they have actually applied an offset inside of the blueprint to make sure that it aligns. And we also did this in previous week. We did that last week. This was the reason why we did it for our enemies. So it is also something to be aware of. Again, as Mike mentioned, if you're friends with your artist, they can do it literally in 3 clicks. It's a pretty straightforward process. But sometimes us as programmers just have to work around it. So it's important to know and pay attention to where your pivots are. Alright, so I'm going to create another particle update, and this one I'm going to call offset position. And just move it up a bit so it's there. And again, it's going to have a direct offset mode, that's fine. And for position offset here, we are also going to do vector from curve. And I'm going to open it up so that we've got it in the curve editor here. Now, for this, we're going to play a bit cheeky. So X and Y, we don't care. So both of these are going to be 1, 1 again. So let's just grab both of these, do 1, 1.
And by the way, really tempting to drag keyframes in a curve editor, but I would recommend doing what Josh is doing, where you select it and type in a precise value. That can save headaches sometimes.
Now, the fortunate thing is I've actually got snapping on. So if I had snapping off, for example, I want to make this around 1. It's going to be 0.99 point something something. So it is generally the better option to just use, at the very least use snapping, but really hard code it. Okay, so this is where we're going to get interesting. For our z-axis, at our 0 second, we are going to set this to negative 0.5. And for our ending point, we're going to set this to 0.11, like so. Now, it may not look that much different here inside of the preview, but when you look at it inside of the engine, it will actually look proper, where it will start at the bottom and then shoot up. Cool. And that means that we've now got our particle effect. But it's kind of boring. Let's give it a bit of let's give it some color. To do this, though, we need a material first. What I'm going to do is I'm going to go back to my content drawer, and I'm just going to right-click and create a material and call this mm_particle master. And then I'm going to open this. This here is what's known as our material editor. If you've already done C1, you may have been exposed to this, but C1 really doesn't get you doing anything aside from base color and opacity. Inside of Unreal Engine, this here is effectively our shader system if we want to create custom shaders. A material in Unreal is a shader, which also means that we need to be careful. Typically, the way that we will do things is we will create a couple of these. These are referred to as our master materials, which is why I'm using mm_ as the prefix, master material. And then from there, you create material instances. So we are going to, this week and next week, we're going to set up 2, maybe 3 of these. I don't know why I'm holding up 4 fingers, 3 of these. One of them is going to be our particle master. So this is for our particle systems. We are going to set up a simple one for our materials, just for a simple base color one. And depending on how we're going for time across the next couple of weeks, we might add a third one to differently color our enemies, to give them some color as well. The reason why they need a separate one is theirs is a bit more complex. Now, you only create a couple of these, and then every single else in your project is a material instance. And it's really important to understand the reason why we do this. Every single one of these master materials is considered an individual shader that the GPU has to compile. If you have multiple of these that are effectively the same, you're creating more work for the GPU because it has to compile them individually and treat them as separate shaders. This adds to compilation time, and it also adds to your frame rate and runtime as well. It can be quite a big performance hit. Just to give you an example, I know Mike's going to jump in, but Capstone a couple of years ago, we had a group that was making a really, really cool game. It was about week 10, and they were really struggling because the frame rate was just tanking. And it ended up being because they had created all of their assets and all of their objects with individual master materials. It went from 10 FPS to over 60 just by that single change. So it makes a huge difference.
It certainly does. So every time the GPU encounters a new shader at runtime, it stalls the rendering pipeline. It has to think, crap, do I have in memory the textures I need for this particular shader? Am I set to the right like rendering mode, like opaque, transparency? Is my depth testing on the right settings? There's all these things it has to go through to make sure it's ready to render that surface how this shader wants. So the least amount possible is very much a good thing.
So there's a couple of different things. One, Unreal is technically capable of doing shader compilation at runtime, but if you've ever played an Unreal, particularly in Unreal 5, if you played an Unreal Engine 5 game where you're moving through the world and you see hitches and stutters trying to play, it's actually more often than not shader compilation. And it's also the reason why a lot of games that use Unreal, the very first time you open them, you might have to wait 5 minutes for shader compilation, because it'll actually do it ahead of time. But the problem is that it still needs to do it. It will either compile them at runtime, or it needs a set amount of time at the start, at least once, and more likely every time you make changes to settings or your graphics card updates, or the drivers update, it'll have to pre-compile those shaders. Again, this is why we try and make it nice. We're not going to cover the optimization side of things here, but there are some really good tutorials online if you plan on releasing anything in Unreal on how to set up your shaders to compile properly so that you don't have games that have hitching and stuttering in them. Because it is the bane of players' existence. I'm sure you've seen them and get frustrated. Alright, let's get back to this master material. This is a particle, so we only need one value. I'm going to right click and I'm going to type in particle color. So this here is actually an existing input. So I'm just going to go RGB to base color. And I'm going to go save and I'm done. That's all I care about. But this particle color here is actually the same particle color that we saw back in the Niagara. So if we attach this material to a particle, it will pass through the color and it'll apply it. Now, I was a bit naughty yesterday and I wasn't practicing what I was preaching. So what I'm going to do now is I'm going to right click on the particle master and I'm going to do create material instance mi_spike particle. So this is a material instance. And when I open this, you'll notice that it doesn't have the graph. All it has is the information or the visual here. And then on the right hand side, it will have a bunch of the override options that you can make. Now, typically you will have more options available here as you create them. Because we're using particle color, that's actually controlled separately. But this is why you would use a material instance, because now every single particle, if I create a new instance for each of them, or really just use this same one, it's going to treat them as one shader without having to compile every single one individually. So if I click on Mesh Renderer now, I can click on Enable Material Override. I can click Add Element, and inside of this index where we've got our material interface, if I do mi_spike particle, I click here, and you can see we're now applying that, that color to it. And if I go back to initialize particle where we have the color mode direct set, if I change this, this is just going to directly change what the color is. And it's going to look a little weird because it actually resets every time I do it, but you get the idea. That's cool and all, but we want to control this from code. So I'm going to do linear color, spike particle, color. Done. I really hope I spelled that correctly because I can't see it. Let's just make sure I spelled that. Yes, I did. Cool. And I'm going to set this to, I'll keep it white for now, that's fine. We'll set it in code, and I'm just going to drag this across and replace color here. And I'm going to save this because we're basically done. Cool, so that is our particle system. Let's set it up in code. So, inside of our project, which I have already opened here, I need to make one change to our build settings first. So this is our build.cs file. In previous weeks, you saw us update this to deal with adding in the navigation system and adding in UMG and Slate and AI and all that sort of stuff. We need two more for this. The first one is going to be Niagara. And then the second one is going to be Niagara Core. So I am now saying that I am going to enable these plugins, basically. So I need these to be included in our base code. Cool. So I'm going to save that. This will actually cause an update in the project, by the way, because you are changing the build settings, so it will need to resync. But we can now jump over to our spike trap and add in a couple different things. The first thing that I'm going to do inside of spike trap actor, because Niagara is a bit cheeky, sometimes the autocomplete for the includes doesn't actually work. So I know for a fact I need to include Niagara function library.h, and I also need to include Niagara component.h. So I'm going to add those immediately because I know that I'm going to need them. And down the bottom here, I'm going to create two new U properties. So there's going to be edit anywhere, blueprint, read write, same as previous. The first one is going to be a U Niagara component. And I'm going to call this spike particle component. The second one is going to be a Niagara system, and this will be that specific system that we just created. Now the reason for this is the component will actually attach it to the object, and the system is used for spawning it in, because we are going to spawn it in dynamically. And that's all we're going to use for now. We do need no, we don't need any new functions. This is going to be really nice and simple. All of our changes are going to be down inside of our onOverlap, where we've already got our enemy. So if the enemy, because we don't want to spawn a particle if it's not the enemy. If spike particle system, so if it actually has a system set, we're going to set this from the blueprint. We're going to create a spawn position. So there's going to be an F vector, spawn offset. Now the reason why we're doing this is because, again, we need to pay attention to pivots. The pivot point for our spike is in the top left corner. We do not want to spawn it there. We actually want to spawn it in the middle of the spike. Now this might look a little gross, but it will work. We're going to do an F vector, and we're going to do 100 times spike mesh get relative scale 3D dot x, divide it by 2. And then I'm going to do the exact same thing except for y. Does anyone want to hazard a guess what this is doing? Just feel free to shout it out. Okay, so what we're doing here is we know for a fact that our cube is 1 meter by 1 meter. And that is always going to be the case. It doesn't matter how big we end up scaling it. We know the default is 1 by 1, so that's 100 units. So what I'm doing is I'm saying, okay, we've got 100 units times how much scale we've got on the axis. So it'll be 100 times 3, 300. So that'll be basically from the start to the end of our mesh. And then we divide it by 2 to get the center. And we do it for x and y, so that we then center it in the position, and then we set it slightly up on Z of 20, because we want it to appear slightly above the base. So that is our offset. Again, it's a bit nasty, but it gets the job done. The next thing that we want to do is we want to do our spike particle component is equal to U Niagara function library, : spawn system attached. And this will then spawn the system and store it in that particle component. So to do this, we tell it the thing that we're going to spawn, which is our particle system that we've already saved. We want to attach it to this root component. Remember, we set things to our root component here. We then want to do for the attach point name. We don't have an attach point, so we just do name none. We then do our spawn offset as our position. Our rotation is 0, because we don't actually care, so it's a 0 rotator. Our attach location is going to be a mouthful. It is E attach location : type : keep relative offset, and true, because we want it to auto destroy at the end. And again, this is a mouthful, but you'll notice that as I was going through this, it was actually popping up and giving me a hint on the type of values that it needs. And that's going to be our particle component there. So that'll spawn in our particle. Let's actually jump over to Unreal, compile to make sure that it is going to work, which hopefully it will, but we'll see. While this is compiling, is there anything that you thought to add, Mike, to what we're doing here?
I just want to just reiterate something I think is important. So just for the Unity and Godot people listening, so quick translation. So the master material, that's essentially your shader. the material instance, that's what most engines would just call the material. So that's the collection of settings that the shader needs to do its job. It's mostly textures, but sometimes it's vector or float data and various other sort of rendering flags. But Unreal's terminology there's a tad unique, but that's how to translate it.
Yeah, so that is important to know, because if you're dealing with shaders in other engines, it will be more explicitly known as a shader, and it'll be part of a shader graph, not a material graph, even though functionally they are basically the same thing. Cool, alright, so I'm going to open up the blueprint for our spike trap, and we'll now have this spike particle system here. And I'm going to set this to be our spike trap particle. I'm going to compile, and I'm just going to hit save, and I'm going to run it. Now, the other thing, as I mentioned, is I can spawn more of these based on the base code. And you'll notice, when it spawns in, I was talking over that one, but it's going to spawn the spikes. However, as you notice, it's kind of, well, it doesn't fill the full thing, so it kind of looks a bit silly. But again, this is where those customization options come into play. If I jump back to the code here, what I can do is I can go... Just make sure I've got the exact code right in front of me, and let's see if I can remember the exact names that I used. Spike particle component, set Niagara variable, we want vec3, so a vector 3. We need a name, it is going to be spike spawn scale, and I'm going to double check that this is correct. Spike spawn scale, yep, happy with that, cool. And I can now give it a value. And I'm going to give it the value of spike mesh get relative scale 3D. So whatever the scale of our mesh is, apply it to our particle system. And again, this means that if we change it so that we want it to be 5 by 5, we don't need to go and change the particle system as well. We just change this particular actor and it'll update it for us. The other thing that I'm going to do is I'm going to do spike component set Niagara variable linear color. And I think I called this something different. So spike particle color, and just again, be aware if you're using American or Australian spelling. I tend to be terribly inconsistent because Unreal uses American by default asterisk most of the time. Parts of the engine actually use English spelling as well. But anyway, I'm going to do F color : emerald. Save this, and I'm going to recompile. Now, we're not going to have time for this, so I will just flag it ahead of time. When the solution code gets released on Monday, it will have an additional material for the spike trap, and the spike trap will also have its own code set up for changing the color. And this will be inside of begin play. So just be aware, it will have that, but it's not something that we're going to have time to code here. But now if we look at it, so when an enemy spawns in, it's going to run over and hopefully not crash because I spelt something wrong. There we go. It's now doing it as our color, and it is now scaling to the correct size. So we now have our spike trap set up so that it's nice and customizable. And as you can see, it kind of overlaps there. So maybe I do want to change it to 0.85 instead to keep it internal. But hopefully this gives you an idea on some of the stuff that you can actually do with Niagara Particle Systems. Again, this is a very simple emitter. It's actually only using a single, it's using a single emitter, nothing else. But hopefully this is of use to you. Next week, we're looking at saving and loading. What we're going to do for that is we're going to add in a level up system for the traps. So we'll actually set it so that the trap, we can, in an Excel spreadsheet, define the values that we want, import them into the Unreal Engine, and then just load those in, basically, and then set them up inside of whatever system that we want it to do. Again, not something that's covered in any of the labs. It's not required for any of the tasks. It's more just something that you might find useful for your custom project. All right, I'll wrap up the recording here. We are also at time, so we will need to hop out, but I hope that this has been of use for people.
Thanks all.